This is the final report of QA system from Team Bandersnatch. Here's an overview of our project. It mainly consists of two parts, question generation and question answer. Question generation. Here are all the tools we used in the pre-processing. In order to better process complex sentences, we decide to split long sentences into small parts to expand our candidate set. We need to find subjects for both cases first using POS tagging. For apposition, we simply substitute everything in the apposition clause to construct a new sentence. As for conjunction, dependency parsing is a good tool to find a conjunction between two verbs and use the same subject to construct two sentences. The final candidate set is filtered to only include sentences with the structure NP plus VP. This is a relatively regular structure and easier to transfer into questions in the future. For binary questions, if there exists an auxiliary verb, we simply move it to the front. Otherwise, we lematize on the verb root to get the tense. We transfer the word do to the same tense at the front and change the verb root to its prototype. To generate questions answered with no, we could simply delete the negation word not if we detect it in the sentence. Also, we could replace the name entity, which is identified by spaces and ER tagger. For WH questions, we use again spaces and ER tagger to find out special entities and generate related questions. For example, the location entities can generate where questions, etc. We design our ranker to follow the prescribed priorities. Questions have to contain 5 to 30 words, and question containing named entities, which often refers to when, where, how many, why questions, will be considered with the higher ranking. We also make sure that the ratio between binary questions and WH question is about 2 to 3. Question answering. The first stage of question answering is pre-processing. For the article, we follow a similar procedure as the way we did in question generation. For the question, we simply remove punctuation and perform canonicalization. Canonicalization is an indispensable part of pre-processing to disambiguate question type and identify the real intent of a natural language utterance. For example, the three questions in this slide all contain the same intent. While meaningless, please tell me and would you rather may fool our system into identifying it as a binary question. Since we're expecting some kind of answer like yesterday morning instead of yes or no question, we can canonicalize this question into an unambiguous and easy to understand form. The second stage of the question answering is to retrieve the most relevant sentence out of the article. We build a mini search engine based on Okapi BM25 algorithm. For each question, we retrieve several sentences, search answers from all of them, rank the generated answers, and choose the one with the highest score. If no answer can be found, we honestly tell you we can't answer this question. The third stage is to identify the question type. For regular question, it's very easy to identify the type based on Penn treebank syntactic tag set and keyword matching. For some special types such as either or, we not only want to identify it correctly, but also want to give an exact match answer out of the given options, like a human does, to make it more natural and succinct. To achieve such goal, we use a combination of spacey dependency tree and regular expression matching to identify such special questions and directly give our answer based on the given options. The last stage is to actually answer the question based on a sentence. For binary questions, we first do a token level comparison between question and sentence. If there is some mismatching or lacking information, the answer should be no. Otherwise, it's yes. To achieve higher precision, we perform a sentiment analysis between question and the sentence. We allow matching between a word and its synonyms and count the number of negations by looking for antonyms, pairs, and negation words. If the total number of negation is odd, the answer is no. Otherwise, it's yes. For WH questions, we used identify type and search for specific name entities in match sentences as our answer. If multiple answers can be found, we score each candidate's answer and use a tiebreaker when necessary. For each candidate answer, we first score them by evaluating how close its type is to the expected type. Then we reward those candidates whose verb root is shown in the question. We also introduce a penalty term for those candidates which appear in the question themselves. If there are still candidates with the same score, we break the tie by evaluating how far they are away from the match snipped. For what question, we extract non-chunks as candidates. Those whose verb root is not shown in the question should be filtered out, and those with specific dependency tag should be rewarded. Same penalty term in WH questions also applies here. For special questions such as either all, we extract all options given in the question and check which candidate appears in the sentence. Then we directly return this candidate in the exact same form as in the question. Finally, this is a summary of our QA system. Thank you.